Hey everyone, this is Manjunath for Data Science Galaxy. Welcome to my YouTube channel. Today, I'm pretty excited to talk to you all regarding the most frequently asked question in data science and machine learning. Today, I'm going to be answering question. If you are excited for this, please give it a like and subscribe if not already done, and stay tuned. Without much ado, let's get to the question. Shall we? What is the best way to learn ML algorithms? I'm quite sure this must be on top of the minds of many of the learners. From time to time, many learners reach out to me mentioning this, and I completely concur and understand where they're coming from. There is a wealth of information available out there in the public domain, but nobody would tell you where to start, what is the best way to learn machine learning algorithm, how do you go about in a structured and systematic way. So this is most important question for anybody to understand, so that you will make the best of learning abilities that you have. So let us examine my proposed solution to the best way to learn machine learning algorithms. First and foremost, I strongly recommend learning machine learning algorithms by way of divide and conquer strategy. Yes, divide and conquer strategy. So I'm going to propose, as a practitioner, as an experienced data scientist and consultant, a 4-step approach to handle and learn machine learning algorithms in a structured and systematic way. Are you excited to look at the steps? Look no further. Remember the structured and systematic approach that I talked about. Now let us check the step 1 and see what are the points that I've got to recommend for learning the machine learning algorithms better. First and foremost, one algorithm at a time by practicing multiple times on the data set. While learning, you take up a particular algorithm. Let us say you're going to take linear regression, for example. It could be in the language of your choice, could be in R, or could be in Python, or could be in any other programming environment. But the key is to take a data set, take one algorithm at a time. What do? You apply and practice multiple times on the same data set. Yeah, multiple times on the same data set. What does it do to you when you apply multiple times on the same data set? It will help you to understand the nuances of the algorithm. It's very, very important to understand the intricacies and the nuances of every algorithm that you work on. How do you go about doing it? Do not memorize. One more time, I'll repeat. Do not memorize. You look up for the syntax. You look up for the details and the explanation about the function or the algorithm itself. Do not memorize. That is where people make mistakes. They try to memorize. Human brain is not meant to memorize everything, and it is not worth memorizing everything. So what is my recommendation? Deliberate practice. Deliberate practice is the key. This I am again emphasizing, saying it from the perspective of my experience. Please perform deliberate practice, taking one particular algorithm on a particular data set and practice it multiple times, so that it becomes muscle memory, second nature, and very natural to you. Yeah. Now let us look at the step 2 of my recommendation for learning the machine learning algorithms. What it entails. First and foremost, let us say you are going to take up a second algorithm, for example, logistic regression, to learn. All you have to do is simply this. Follow step 1 that I talked about already a few seconds ago. Word of caution. This is where I see a lot of the learners, in their eagerness to learn the algorithms faster, make mistakes and not able to leverage methodic and systematic learning. What is that? Word of caution. Do not try multiple algorithms on a single data set all at once. Underline the word all at once while learning, until you are comfortable with multiple algorithms. Underline until you are comfortable with multiple algorithms. This I am saying from the practical experience. We will have enthusiasm to go about apply multiple algorithms without knowing individual algorithms in a concrete fashion, but would want to learn faster by applying multiple algorithms on a data set. We end up making mistakes because you will not be able to appreciate and leverage the learning better. So what I say, you should be resisting the temptation of application of multiple algorithms on a particular data set until you are comfortable with applying individual algorithms thoroughly, so that you could go ahead in an incremental fashion, one algorithm after the other, to learn. Yeah. Now let us see and understand what the step 3 that I want to talk about in terms of my recommendations to learn machine learning algorithms. I want you to be comfortable with multiple algorithms. following the approaches talked about in step 1 and step 2. Let us say, for illustration, you are going to learn 3 machine learning algorithms. One is logistic regression, second is, let us say, decision tree, and the third is random forest. Please realize some of these algorithms could also be used for regression, but let us say we are going to use for a classification setting. Now you are comfortable with the decision tree, logistic regression, and random forest. Once you are comfortable, what you would do next? Try these 3 different algorithms on the same data set. Hope you are able to appreciate what I'm trying to get at. You have learned individually decision tree, logistic regression, and random forest. Now we are comfortable with it. Now we are going to apply these 3 algorithms on the same data set for a particular context and setting. What you are going to do next? Voila! Now you are in a position to compare and contrast these 3 algorithms. By using what? By using model performance metrics. What is the purpose? To basically understand which algorithm or set of algorithms works better or suited better for which kind of a scenario. So here what we are doing, we have taken 3 algorithms that we are quite comfortable to apply in the same data set and use the model performance measures, let us say the classification metrics in this case, to compare decision tree with random forest with that of logistic regression, and we are able to compare and contrast and understand the intricacies in terms of which algorithm is the best suited under which conditions, why and why not. For learning, this is where it matters. Your ability to differentiate a particular algorithm and see which algorithms works better in which condition makes a huge difference for the application of the algorithms. Remember, nature of the data should lend itself logically to application of the algorithms. So your model metrics here and the understanding of the algorithms will keep you in good stead to make use of, let us say, a first go-to algorithm for classification could be logistic regression given certain setting. Then you could be going about looking at the rest of the competing strong algorithms. So this is how you are able to learn methodically the algorithms. We are left with one more step, step 4. Let us go ahead and examine without much ado. Shall we deep dive into that? Here is the last step that I'm going to make recommendation about. Before I talk about the last step, that is step 4, it is imperative for me to summarize steps 1, 2, 3. So what have we done? We have gone about learning systematically in a structured fashion multiple machine learning algorithms employing steps 1 to 3 so far. Are you going to stop at that? No, you don't. You go ahead and do what? You go ahead and benchmark the benefits and the limitations of each and every algorithm that you have learned. So let us say you have learned 3 algorithms, decision tree, random forest, and logistic regression. Now you are going to use the performance metrics and performance diagnostic to benchmark the benefits and the limitations of one algorithm over the others. So keep in mind, you as a data scientist is paid to solve a particular business problem. Let us say you are faced with a particular business problem of classifying customers into defaulters and non-defaulters. So what you do, you convert the functional problem into a machine learning problem. You take the data and explore the data to understand first the problem itself, then to see how about applying the classification models on the data for solving that particular business problem. So what you have in your repertoire? Set of algorithms using steps 1 to 4. You've got decision tree, logistic regression, random forest, for example. These 3 algorithms you have, and you've also used the performance metrics to benchmark the benefits and the limitations. So now you go about in the form of selecting a particular algorithm after having understood the data using exploratory data analysis and application of unsupervised learning. Now let us say you're going to take up decision tree for the first algorithm. Why? Because you would know the data at hand lends itself to application of decision tree better. It's another matter, I'm not getting into it, the holy grail. Decision tree tends to overfit, but for an example, you would take decision tree. You also know the decision tree limitations. Then you go about looking at, let us say, random forest, which is a better method because which is an ensemble. Yeah, this way, this structured and systematic approach to learning machine learning algorithms not just has given you hopefully a better way to learn the machine learning algorithms in an optimal fashion, but more importantly, it has increased your ability to solve business problems multifold for a given problem and setting in terms of bringing to bear the applied knowledge of several machine learning algorithms that you have learned and you are ready to apply on the business problem. You can see how much of rigor I've put in to create this content for you, because I've used all my practical experience and my tacit knowledge to come up and concise this into a 4-step divide and conquer approach strategically for learning any machine learning algorithm. So all in all, you could employ these 4 steps to learn any machine learning algorithm in any programming environment on any data set. With this, I've come to end of this video. Hope it was useful. Please give it a thumbs up, share it with your friends and your network. Subscribe if not already, and stay tuned for more. Don't forget to hit the bell for notification whenever we release a video. This is Manjunath signing off. Thanks for watching, and bye bye. I'll talk to you in my next video.